So good afternoon, everyone. I'm Abhaas. I am here to present, I work at ACCESS-NRI in the land surface group. So here, today I'll be presenting our work done in improving testing in cable land surface model. Specifically, we worked on adding range checks to certain variables in cable and adding streamlined functionality for checking them at certain time steps. And our use case was that it would provide climate scientists with more logs and feedback to develop more features more accurately. So for that, it would provide them with a faster feedback loop, essentially. So for that, we added two flags, essentially, one related to the frequency of the range checks, whether to check them at all or whether to check them only on writing certain files or at every time step, and the other flag was related to out-of-bounds behavior on whether to have logs or to exit the program. Okay. Yes, thank you.
Hi. So the UKMO is planning on moving all their codes from SVN repositories to GitHub repositories in the next year or so. And it means everyone working with the UM, for example, is going to have to change their workflow. And it turns out that we just did the same thing for cable about a year ago. And so I wanted to present here what it meant for the community, the challenges that were seen, but what was really great was we saw benefits right from the start of changing and mainly around collaboration. So I invite you to come. It's a great story.
Okay. Have you ever tried to perform any task related to access models like convert a UM files to a netcdf, or modify an ancillary or a start file, or perturb an experiment that failed due to initial conditions instability, or maybe search a stash variable information, or perform any other task related to access models, and you found it difficult, confusing, there was no documentation around, and the scripts were all scattered around and outdated? Well, AMAMI should make the life easier for you, and should make this task easy, straightforward, well documented with a version and all in one package. And we are currently developing that at ACCESS-NRI, but we need your support to be able to understand what tasks are needed to you and how to make it amazing for your needs. So please, I don't have a poster, but what I have is in fact a QR code. Please cast this, and is also on the poster board. You find a few ones on number 5 poster board. Please take the questionnaire. It literally takes 2 minutes. Thank you.
So I want to do exactly what Davide was just talking about. We want to take a coupled model and we want to kick the tires and work out what is going on with Antarctic sea ice. And we would like your help to come and talk to us about how to design these experiments. So Hannah Dawson is the one who will be running these models, and she's done some initial condition perturbations with Access ESM, warming up subsurface ocean, and we're trying to look at the impact of that on the sea ice around Antarctica. But we would love your ideas about other ways to perturb it, start it, do funny things with coupled models. Please come and have a chat.
Hi everyone, I'm Jasmeen, and I'm here to present Access Hive to you all. So have you ever wondered about the difference between a model component, and model configuration? Or perhaps you want to learn more about running a model. During the poster session, we'll walk you through in detail of what Access Hive is and how to make the most of it. In simple words, Access Hive is a term that's used to describe publicly available resources for the Access community. It comprises of 2 components, Hive Docs, as in the Hive Docs and Hive Forum, which are both aimed at sharing knowledge and fostering collaboration across the Access community. So please say hi in the poster session, and we would love to have your feedback on board. Thank you.
So there's a link between La Niña events and above average seasonal rainfall in Australia. But we know that above average seasonal rainfall in Australia is caused by very few very rainy days, and not by some increased average across every single one of those days. So therefore, maybe we can find a link between those individual very rainy days and those individual rainy patterns and that far field indicator like La Niñas. So in the black here, I have contours of mean sea level pressure over eastern Australia in the 27th of February 2022, which is the Lismore floods. And then I've looked through the ACCESS large ensemble for days that match those mean sea level pressure conditions. And in the background here, we have the sea surface temperature anomaly from those 30 days. And there's some significant patterns in that, such as something that looks like a La Nina in the tropical Pacific. And I'd love your feedback on where to take this next.
Hi, I'm Kial. I'm at ANU here. So sea ice is, so observations of the thermodynamics of sea ice are kind of scarce, like it's really hard to make, and there's very few of them. They typically have large uncertainties and they're biased and they're sensitive to the synoptic conditions under which they were taken. And there's especially very few observations of warm sea ice, so sea ice that's warmer than about -10 degrees. In ACCESS OM2, that accounts for about half of the sea ice pack volume. So we think it's much more convenient to make measurements of sea ice thermodynamics in the lab. And so that's what I've got here, and that's what the video is that I'm showing. And we take these thermodynamics and we can put them into SICE, and we've done that, and we see that the global sea ice pack is quite sensitive to the thermodynamic modules that we're using, and it's a step in the right direction in terms of the summer sea ice bias low that Elio was showing earlier.
Hi, so I'm Lachlan from the ACCESS-NRI. I'm just going to be talking about a little bit of work I've done making running cable spin-ups much easier. If you ever tried to run a cable offline spin-up, you know it's a bit of a complex process. It's a shell script which is about 1,000 lines long, which is opaque and no one knows what's going on. So I decided to hook into some of the excellent work that the PyU team have done with the PyU tool and make it easier for people to run models. It's very clear. You just provide a couple of name lists with the options that you want to change in each stage. And pass it through PyU, and you get all the the benefits that PyU comes with. You can distribute these configurations to your peers. You have provenance for your configuration. And ask me if you want to learn how to do it. Thank you.